So we would like to compute the limit of this sequence, square root of n squared plus n minus n. And the reason we're doing this is because we would like to anticipate what we will do with functions and limits at infinity. So here the idea is that we have the difference of two things that tend to infinity, and that can be considered pretty much as problematic as having the quotient of two quantities that tend to zero. So it's what one might call an indeterminacy, which is a situation where you cannot commit yourself right away to a conclusion without further examining what is going on. The reason I'm saying this, if we had two sequences, one tending to 3 and another tending to 2, without even looking at the sequences themselves more deeply, you could say that the limit of the difference is 3 minus 2. But here, when we have two sequences that both tend to infinity, that's not possible to do. And the trick is to try to get to simplify this expression so that we can actually argue as usual. So this is not a rational function. And what we're going to do is multiply and divide by the conjugate quantity in order to get rid of the square root, at least on what is going to become the numerator. So we multiply and divide by quantity that has a plus, which, like I said, traditionally we call it the conjugate quantity. And we come up with the limit as n tends to infinity of square root of n squared plus n minus n squared over square root of n squared plus n plus n. So this is the limit as n tends to infinity of n squared plus n minus n squared. The square root and the square cancel each other. And now we have a nice cancellation, and notice that we don't have any negative signs. So we have really a situation that resembles what happens when we have a rational function. So what we would like to do is factor out the largest quantities from each numerator and denominator separately. To achieve this, on the denominator, we start with the square root, and we multiply by, we factor out as we would have done normally, n squared, which is the strongest term. And in our next step, we're extracting that n squared outside of the square root. So square root of n squared is n, and inside the square root, we're left with 1 plus 1 over n, and then we have a plus n. And overall, it's really the term n that is, again, the strongest one on the denominator, so we end up factoring this out, which is very, very simple in this case, because we have, because it's present in both summands. And this is what we get. And now it's cancellation time. Again, it's useful to remember, it's useful to think of the numerator as being n times 1. So we cancel these two things and we get the limit as n tends to infinity of 1 over square root of 1 plus 1 over n plus 1. And the only thing which is variable here is this 1 over n. What's the limit of that? It's 0 as n tends to infinity. So we would have pretty much, now we can do our square root of 1 plus 1, which is 1/2. And that's all. Soon enough, we're going to see this very same limit with n instead of x. I'm sorry, with x instead of n, and x will still tend to infinity, and the treatment will be precisely the same. And that's all. Thanks for watching.